Hello, I'm Alex Sexton. I am currently a designer at Stripe by official title. So like most designers today, I want to discuss front-end security with you. I think a lot of times in the front-end community, we rely heavily on our tools, whether it's our frameworks or whether it's our other teammates in order to do security and to make our application secure. And I think that leaves gaps in our knowledge and in our applications. So today I want to fill in some of those gaps and give you kind of a state of the world on where front-end security things are and how likely it is you are to build a secure client-side application. The state of the world. Anyways, here. The title of my talk is Script Alert 1, which is a reference to the script injection that we all kind of inject into all of our friends' test applications. I put it into the guest book application here, and they didn't appear to have any script vulnerabilities. But let me know if anyone gets an alert with my name in it. But behind it gets to the core of how I'm going to draw a line on what front-end security is versus back-end. Anything we can inject, but there's plenty of vulnerabilities in the content injection XSS space to not have to worry about the server vulnerabilities and updating dependencies on the back end and all that kind of stuff. So we have plenty of our own. So I'm going to jump pretty fast through the basics of XSS just to get everyone on the same page. I'm also going to talk about content injection. It's very similar, but I kind of want to make a distinction because it gets pretty interesting pretty fast. So this is a static HTML page, and it says welcome friend, and it's pretty secure. It's static. It's not content injectable because there's no dynamic content to inject through it. So let's make it dynamic. Now we have some dynamic content. This is roughly ERB, I think. Sometimes I do Ruby, so I chose that. Ruby or ERB is a nightmare for escaping. Depending on how you configure it, double equals either means escaped or not escaped, which is a pretty good thing to be able to switch. But let's say user isn't escaped here. So if users are nice, this is fine. User is Angus, welcome Angus. If the user is mean, then we'll faithfully inject a script tag, and the browser will faithfully run that script tag. This is XSS, cross-site scripting vulnerability. It will, yeah, there it is. Content injection is very similar. It's just maybe you can inject a script tag, but you can inject something else. In this case, we can inject a link. Maybe the href here is also one of those JavaScript : links if you can't inject a full script tag. You can also inject styles. Here's a style tag. You can maybe inject style as an attribute. There's a bunch of different things that you can inject on the page other than just words and scripts. And vulnerabilities span that whole space. Images, all kinds of stuff. So before I go too far on, I did want to call out one very, very, very common script vulnerability that you guys are all, y'all are all putting into your pages, and that's with Redux or any of these things where you're trying to rehydrate data on your page. This was in the Redux example documentation for 2 years, and it kind of tells you in your templating library inside of some Express file to just JSON stringify your app state and then output it. But in reality, if you set something like this to your username, you now have a script injection, and that actually seems kind of weird because it is inside of that quote block. Why is this a script injection? We haven't done the classic SQL end the quote and do anything like that. That would all get escaped by the JSON stringify. But the way the HTML parser reads this is a script exists until a closing script tag happens. And so it looks more like this. It's a invalid JavaScript block followed by a valid JavaScript block that alerts one, followed by some garbage that it prints out to the page. So you should stringify and then escape and then parse the stringified or whatever. Anyways, so let's jump back to 2008. Before we were all building React apps, we were all mostly using jQuery. Ruby was on Rails. Node.js didn't exist yet. So what was the state of the art of front-end application security? We weren't doing a ton of dynamic stuff yet, so it was escape your user inputs. If you're going to output stuff, escape it. And so we built templating languages that escaped by default, ERB and Django templates. That was pretty great. It was a good time. We also said if you're using jQuery, instead of using the HTML, which pipe down to inner HTML, which would allow script injections, use this text, which would, depending on the browser, use inner text or text content. Someone can check MDN. And it wouldn't be able to inject. So everything was fine. We solved it, no problems. But tools with safer defaults like those templating languages were really helpful, and we solved a lot of problems and probably prevented a lot of XSS, but certainly security wasn't a solved problem at that point. There's always someone who can break an assumption that you've made. So jump forward to 2012, and we get content security policy. And this is kind of where we catch up with maybe some other environments for security practices. The web was JavaScript was a bit of a mistake, and you'll hear, I think Croc used to say that being able to load scripts across different domains was a mistake, and it is a vulnerability, and we shouldn't have ever done it. But I think that's what made the web successful. And so content security policy kind of allows us to do that, but it allows us to do it in a programmable way, and we could flip that security model on the head. Everything is blocked by default. Nothing can load, no scripts can run, no styles can run until we say, we want to be able to load scripts from only this place, we only want to run them this way, we can only use these features, and everything else is turned off by default. This was a massive improvement. This is what one of them looks like. It's a header. It's on version 3 now. It's updated since 2012. And you create an allow list. So by default, nothing runs. And then we can override that and say scripts can run as long as they're hosted by this same domain. And also Google Analytics can run their script, and only we can run styles on this page. Huge step forward in blocking XSS. That means if someone script injects your page, the console logs and says, this has been blocked, and it'll even log back to your server that says someone tried to script inject your page. It's pretty great. You should already be using this. If you're not using this, you should feel bad, you are bad, whatever that saying is. It's 5 years old. This is kind of baseline security stuff, and I know not everyone is using it, and so don't actually feel bad, but go implement it. I'm not even going to cover it too much. I'm rushing through it because it's not the interesting part. It's pretty easy to implement. There are websites where you can generate one for your site right away, and it helps you super quickly. So what's wrong with CSP? I have to be clear that CSP is incredible. It's good. It was a good solution. It provides a massive increase in security, but we kind of do this same thing over and over again. We see a security problem, and then we build a layer that can help protect it against that security problem, and then we wipe our hands, we high five, we celebrate, we say there's victory over the hackers, no one can hack us anymore, content injection is dead. But the key to the content security policy that was nifty was that it actually built on top of user escaping. User escaping is important, especially if you allow certain things, and content security policy is important. And this is an idea that I think is really important whenever you're building up a security strategy for your client-side code. CSP didn't replace escaping user inputs. So this concept is often called defense in depth. There's a Wikipedia page for it, so you know, oh, this is behind a little bit. Okay, the defense in depth. There's a Wikipedia page for it, so you know it's real. The NSA uses it as their strategy for their system, defense in depth. It's based around the idea that there's that no single layer of security can ever be fully secure. It can always be bypassed. But stringing a bypass through many layers of security is much more difficult because one layer might protect against the vulnerability of another layer. So defense in depth is also sometimes called the castle approach, which I didn't know till recently, in reference to the fact that a castle has many layers of security. It has a forest, perimeter guards, an outer wall, an inner wall, locks, crocodiles, sharks with laser beams attached to their foreheads. It's multi-layered. And the approach is if the outer wall deters 90%, the inner wall deters 90%, you now have a 99% deterrence against attacks. Two-factor authentications on phones is another good example of a defense in depth. But like CSP, it isn't foolproof. Like the idea that I have to steal your phone and your password in order to get into your account is a good one, and that's a good thing to implement, and two-factor authentication is good. But I can also sometimes call T-Mobile and tell them that I'm you and that I lost my SIM card, and please can I have my phone number back, and now Google will faithfully send me your two-factor authentication codes instead of you. And then it becomes a game of deterrence. Do you have enough protection in place to make you not worth attacking? It's just too much effort to call T-Mobile that many times or something. So we're going to have to build a lot of walls because I think the current state is still pretty bad. I think there isn't really an application that I know of that is 100% secure. And this defense has to extend way past our front ends because we have to do like employee hiring checks, and we have to do security of physical access to our devices and data minimization and encryption at rest and user education so they don't fall for phishing attacks. There's so many layers of security for this defense in depth concept. But outside of the ethical implications of being careless with data, you know, it's certainly not good to lose your users' trust for your business. Is there a strong reason, is there a strong business case to go the extra mile to prevent vulnerabilities in your software? And this is a recent topic. It's actually pretty strong evidence that you can leak the entire country's social security numbers to the dark web, and then nothing happens to you, and there are no consequences. But world governments, while slow, are starting to enact laws around things from mostly the reaction to the Equifax hacks. It's early days, but you've probably had tasks at work for handling GDPR or strong customer authentication or the cookie law, data localization law, where you have to keep data in the country that the people are at. So these are the beginnings of governments responding to something like Equifax. And GDPR is huge. The British Airways was fined a pretty massive amount for a GDPR breach, as well as Marriott. So there are now business case reasons to go to your manager and say, hey, if we're not secure, we can be fined this much money that we don't have. So Facebook and Google have leaked data, and they're kind of the biggest. The government leaks data, your hotel leaks your data, your insurance providers leak your data, your cell phones, your health providers, your banks. They've all had breaches. You all know about them. And they're all vastly better funded than you for the most part. So if those people can't keep your data safe, how can you possibly do it? Who's safe? No one is safe. I very seriously doubt that there exists a system that is perfectly safe. We haven't designed technology that works that way. So in practice, it's kind of a subjective calculation on if you're doing enough to make it not worthwhile compared to the next person. So it's not who runs the fastest, but it's who's the least tasty. I don't know, something. Who's the tastiest? You don't want to be the tastiest target, something like that. So even if you build the perfect castle with the most layers of security, can it be defeated? And I'd say, you know, what beats a castle? Probably Russia. If you pit Russia against a castle in a fight, I'd pick Russia. They have bombs and stuff, and I'm pretty sure that, like, I don't know. It seems like a good bet that there is no amount of security that you can do to beat them implanting vulnerabilities inside the chips that you do, or cutting into wires and splicing in, or any number of 0 days that you could never know about. And so now's the part of a security talk that everyone likes, which is I show you things that I didn't think of, that other people found that are vulnerabilities that they're really smart. And so here's my HackerOne bug bounty page. I have successfully submitted one bug bounty. It was to Yahoo at the time for the fantasy football app. And I could script inject the description page inside of my team. And then any team who played me would see my description the week they played me. And I would load an iframe of their settings page and then change their name to something that was bad about them and good about me. And so it'd be like Alex Rules, Mark Jules, and that would be their team name every time that they looked at the app. It was fun. And then after the season was over, I submitted the vulnerability. To be clear, I got last place in the fantasy football league, but also I got paid the most because this vulnerability paid out like $1,500. So better than the pool. So an unnamed company had a receipt page. I'll let you guess who. It had a decent content security policy. It blocked inline scripts and a bunch of other good stuff. It was pretty big content security policy, probably too big, definitely too big. But that was good. But I got this, or someone got this report, and it was injected. So here's an alert popping up on a receipt page. And when you're finding a vulnerability, you're looking for something like this being injected somewhere into the code. And someone wants to just inject an alert, but really what they could do is, steal information off the page and then extract it somewhere else. How am I doing? And they might steal your cookies and send the cookie information that might steal your csrf token, extract other information on that receipt page. And so if you can alert, you can probably do something much worse. And so this is kind of how vulnerabilities are submitted. And you'll notice in that screenshot, there's a bunch of different things that are being tried. So one of the things that's being tried is if you inject an image with a bad URL and then the on-error handler fires, then maybe the alert will run here. That didn't work because inline scripts were blocked. I just told you inline scripts were blocked, but in order to make this simple, imagine this script tag was a foreign request to another domain. It was something like this, where the alt tag for the logo was constructed outside of the template language, so it didn't get the escape. And so you had supernormal XS, no big deal. There was CSP, and that CSP actually blocked the thing that I thought I should block. I went to go check someone went to go check the CSP, and it should have been blocked. There were no nothing on that domain that was allowed that I could see, and so I wanted to dig deeper because certainly the alert ran. So CSP bypasses is kind of the fun part of this. CSP is the state of the art, and bypassing it is a pretty simple concept. You're not bypassing the fundamental CSP technology that the browser implements, but you use weaknesses in the allow list that someone wrote in order to achieve unintended results. So it bypasses the intent of the CSP author, not the browser's implementation of the CSP specification. So it's anything that I can use in your rules that you didn't intend for me to. So here's that same content security policy from before. But if we wanted Google Analytics to work, this is an oversimplification because it can't do like the 1x1 pixel PNG or the XHR request in order to actually do analytics requests. So it would probably look more like this. So we could do XHR and image loading. So now Google can talk to its servers. But we've already introduced an interesting side effect that maybe was unintended. Anyone who can run code on our site can now exfiltrate data back to their Google Analytics account because we're just allowing the whole domain wholesale. So when you add Google Analytics to your page, you're also adding a side channel for extracting data off of your page to a different analytics account. And you make that trade-off. Maybe that trade-off is okay. But back to this. This page had a big shared policy, which meant that the marketing page and the receipt page in question shared the same policy. And the marketing page had an ad provider that was running on it, and it's always the ad provider. So let's call it adprovider.com, and they let you use images as the ads, or because they're an ad provider, they also let you use SWF. And I'll save you a groan. They of course did not allow SWF files because that would be ridiculous. This wasn't that long ago. But the script for the provider was naturally still required to show the images, the JPEGs or PNGs or whatever. Anyone could sell ads on the platform, and the attacker bought an ad and uploaded one. And that upload looked like this. It was a SWF file, even though we don't allow SWFs, but let's try to load a SWF file as a JavaScript file because you had to pick between an image or a SWF file, and SWF is vaguely JavaScripty. There's a bunch of like byte level headers that you need inside of a SWF file, but if you swap out null characters, which are required in the beginning with tab characters, things seem to work okay. And then fireworks SWF, I believe, is what FWS, that's kind of like a prefix header. And then you can inject some stuff that is valid SWF headers. And then you have those little quotes there. And then you eventually get to the alert one somewhere deep in there. And that's a pretty nifty hack, except for you may notice, somewhat helpfully, FWS is undefined, and there's no let or anything like that. And so this will throw FWS is undefined, and we're saved. The hack didn't work, and he sent me, I got so close, this is going to work. And of course, you can't inject like a little bit of a script tag in order to say FWS equals 1, because that's the whole point. We're trying to load a script. We can't run a script. And then like 4 minutes later, he sent me this. Now he injected the script with an ID of FWS. And fun fact about the DOM is that every element with an ID turns into a global variable on the window object. So now you can successfully run a hosted script on this receipt page using a SWF file that was a dual SWF file and JavaScript file, and inject a global variable into my page. Insult to injury, someone's page. So I'm just going to do one more example since we're pretty low on time, but This is a pretty recent exploit that someone else wrote about, and I'll somehow share. I'll tweet out the people who actually figured this stuff out, but this one's pretty nifty. So totally different website that I have nothing to do with, and I didn't have anything to do with the other one. This is a simplification of the content security policy. Nothing is on by default. We're going to turn off all JavaScript. The script source none says I can't write inline JavaScript. I can't include my own JavaScript. JavaScript is completely turned off. But for some reason or another, whatever the demands of the page were, I can use a bunch of different styles and images. Let's say it's some third-party content page where you put like a meme picture and you can say, I don't know, who cares? This is what it was. It's a pretty strict policy because you can't run JavaScript. How could you possibly extract any meaningful information off of a page with this policy? I'll show you. CSS. CSS is a programming language. If anyone tells you that it's not a programming language or that you're not a programmer because you program CSS, show them this hack, and hopefully they will change their mind. They won't, but whatever. So the most common way that a CSS hack is done, there are many, but you use selectors to find out things about the page and then trigger a request that extracts that information back out to a different server using something like a background image. And so you might have something like this on a credit card checkout page. This isn't true. But if you want to know the billing state, maybe that's information you're missing from users that you want to extract off the page because you can inject a CSS file. And that's the only thing you can inject is a CSS file. You can write 50 selectors that use the value, the attribute equals selector in order to find out which of the state matches. And then you can fire off a request using a background image, and then you just return a blank image. And you've now exfiltrated the state that this person's billing address is connected to. Pretty nifty. Who cares about states? Not that interesting. csrf tokens are much more interesting. But the values are super long. They're often base 64 or something even more complex. So all we can do is inject a style sheet. How can we steal a CSRF token? That would be pretty amazing because then we could take that CSRF token and then make requests on behalf of the user. We could do anything the user could do just by stealing the CSRF token. Pretty nifty. So this is one way. It's not a good way, but it would work. You'd have to have a 41 gigabyte file that you load as CSS, and the whole browser would crash, but maybe it would hit before, I don't know, something like that. It actually gzips pretty well. I tested it out. A lot of repeated characters, but the complexity isn't manageable without being able to kind of program the tests. So what else can we do? And the trick is actually in the import statement, and this is pretty nifty. To me, at least, probably not actually that nifty. The specification for import statements is more or less synchronously request the file that's referenced and then logically replace the import statement with the contents of that file. And so pretty much all that means is that you're going to stick the I finally hit the space bar like I said I was going to. So you have an import statement here, and then initially the page will show the .thing class as blue, and then some file.css eventually loads, and it had this content in it, and you logically place it above that, but it has an importance. So now, after that file has loaded, that .thing class is red. And this is pretty nifty because it can control the requests out of order, or the rules out of order, which is the key to this hack. So imagine we had a very simple CSRF token, 102, or 012. I don't know why I chose that, but let's do it. And I created a CSS file like this. I have an import statement that requests some CSS file on my hacked server that I'm running. And then I put in some attribute selectors. But now we're using the CSS starts with attribute selector. And we can run a series through any valid character in the CSRF token. So let's say it's alphanumeric or something. And so there are, 36 characters that you'd have to run through. So there'd be roughly 36 lines of CSF where you checked the beginning and, maybe capitals, so 56, something like that. And then we've made this request at the top, and this is the trick. We don't return anything in that request. We just let it wait. And then we wait for the request to one of the background images to fire, because surely the CSRF token must start with one of those characters. And once we have it, we know the first character. Then we can return the script above with new content. That's our own server. We're waiting to see which the image is. I already said all that. And so now we know that it starts with 0. And so we can do the next line of code and check the same 56 characters again. And we just run through. We use the starts with selectors until we match the full equals csrf token. And we've created a loop in CSS with an import statement. And eventually we get the csrf token. It's a CSS-only csrf token extraction vulnerability. It's small and it's fast and it's easy to implement. It has all the features of a modern JavaScript library. It works in all modern browsers. And technically, the only thing you need to inject it is a single import statement, just the thing to get it all going. So you need about, 10 characters? It's pretty amazing. I don't know who figured this out. I do. So this is my glue. You can never assume anything is secure, and I don't really have a lot of good advice for you outside of the following. Do defense in depth. Do as much as you can at every layer. Never say, this layer is not secure enough, we shouldn't do it, because it may be the thing that catches it along the path of that depth. Have a really good content security policy, because that ends up being a pretty good tool, even though there are bypasses. Run a bug bounty, so the bad guys send you the vulnerabilities instead of the dark web. Reduce unnecessary access to data. That way, whenever you do get hacked, the hack is minimal. And try not to get on Russia's bad side. Thanks.